Yeah, today I'm going to be presenting my opinion on the future of mine surveying and give an overview of what automated spatial data acquisition means for mining. And whilst this future does focus on open pit surveying, a number of these concepts and ideas in terms of data management and interpretation is very relevant to the underground surveying profession. So before this year, I've had what could be described as a pretty traditional surveyor's career and absolutely loved every minute. This latest move into Airobotics could be perceived as a bit of a tangent, but hopefully this presentation will give a bit of clarification about why I am extremely excited for the future and the mine surveying profession. But before we begin, I'd just first like to set the scene of the current state of the industry. Currently, business is booming across all commodities. Prices are up, but it's extremely important that we don't rest on our laurels, because as investment increases in overseas operations, Australia must continue to maintain their position as a world leader in efficient, safe mining. And this means that we must work smarter, not harder. It's no longer just about volume of dirt moved, but how much each tonne costs to extract, which is why Australian companies are investing a lot of money in innovation and technology to drive efficiencies and operational excellence. And thus, mining is undertaking a digital revolution, which we should all be extremely excited to be part of. Technology is moving jobs up the value chain, out of pits and truck cabins into air-conditioned remote operating centres. Today, mining groups boost data gathering sensors, drones, autonomous trucks and trains, and this truly is just the beginning. So these technologies you can see here, these were all just concepts only a few years ago, and they've now been rolled out across sites across Australia, and they've proven value and it's now scaling within organisations. And it's quite unique how all these technologies rely on each other. The automated drones, that feeds the data into the digital mine. The digital mine is utilised by the auto haul, and it's all controlled and operated by the remote operating centre. However, is this something we should be worried about? Is automation a threat to our jobs, and should it be challenged? Well, there's a recent study from Oxford that they did a survey, and 63% of all workers believe that their job would never be replaced by automation. But despite these beliefs, the Oxford study actually argued that almost half of today's jobs could be automated in the next 2 decades. And I suppose just a show of hands, like in the room, who is concerned about automation and jobs in the future and things like that? Yep, so we've got a few. No, very good. All right, well, look, the reality is that automation, it doesn't replace jobs, it replaces tasks. And these are typically the mundane, repetitive tasks. It frees up time, which I know we're all short of. There's not many mine sites that have a full team of surveyors, so that we can focus on efficiency and productivity. There's currently across the board, and this is across all divisions, that it's estimated that we spend about 60% of the time capturing the data, and actually only 40% of the time looking and analysing this data. And I suspect for survey, it's probably even higher than that. We're probably looking at about 70-30. And we really want to flip that on its head. So we're actually spending less time capturing the data and more time looking at it and understanding what it means. Like, I truly believe that by automating some of these daily tasks that we do every time, it's going to increase the value of a surveyor as we transition more from a service-based role to one which actually starts optimising and analyses and provides value to companies, chasing those 1% gains which have huge ramifications on the bottom line of companies. So, but what is the need for increasing all this data, and how are operations increasing and managing this data? Well, data, when investigated, helps locate mineral veins, determine risks and streamline operations, which is why companies are investing so much in revolutionising the collection. Everything is now a smart device relaying data, and the management of all this data is going to be a huge job, one which I believe surveyors have the necessary skill set to undertake. Understanding connections and correlations between this data and the near real-time spatial data sets will give a greater understanding of compliance to schedules, compliance and profitability. And it's important to know that correlations don't imply causation, and understanding the correlations and which are very relevant will be a very important role. So how potentially could our job change? And this is just putting it very crudely. Currently, geos, they find the resource, Engineers, they work out a design to extract the resource. Surveyors, we set up this design and then we pick it up to ensure that it's been done correct to plan. In the future, yeah, sure, engineers might still find and design. However, I believe surveyors could transition to a role, again, looking at all this data, undertaking like the analysis and optimization, the micro and macro level investigations into each process, asking the questions, what is working, what isn't, why isn't it working, and what could we do to make it work? So, how can we prepare for this future? What needs to happen? Well, there's going to be obviously some obvious investment in data storage, security, computing power, but more importantly, as surveyors, I believe we must embrace our role as data managers. We have a unique skill set that can be harnessed to ensure the management and quality of all spatial data. I believe our role will become highly collaborative, where we discuss system bottlenecks and inefficiencies with various stakeholders such as supervisors and management. Once solutions have been implemented, it will be tasked a survey to monitor that data to ensure that these improvements are achieved. So this leads on to the next generation of mine surveyors. Does traditional curriculum need changing? As we all know, graduate numbers are falling. We're just not getting enough graduates out of the system at the moment. And this could be because the traditional classroom is changing. We're now in the iPad generation. The way we attract students to surveying may need to change. With such a big focus on technology in the young minds of students, the perception of a surveyor and a hivers walking around stockpiles may need to change to one of which a highly collaborative role, analysing and optimising huge spatial data sets, utilising the latest technology. An evolving career which begins in the pit and then ends up in a remote operating centre, managing the integration of all this of all these data sources. So now I'd just like to go on a bit of a tangent and actually dive into this future. And I just want to give some small examples of what automated data acquisition means for mining. But firstly, let's answer the question, why automate? Well, to answer that question, I guess we could look at the history of Airobotics. We started as your typical drone service provider. We did weddings, real estate, photography, and the odd spatial data set. But throughout that process, we discovered a gap in the market. Our enterprise clients, they wanted routine, frequent, reliable, consistent data. So in order to streamline operations and remove variability, we removed the human out of the equation and developed a fully automated industrial drone system. This docking station that you can see here is about 2 by 2 and weighs approximately 3 tonne. It has the drone itself, Optimus, is 1.8 metres tip to tip, and it has a robotic arm which removes the payloads, batteries, and allows for fully automated 24/7 operation in an impressive range of weather conditions. So we realised early on that mining was a natural fit. Our system was developed entirely with the harsh mining environments in mind, and this environment's quite unique in that it's changing all the time, operating 24/7 and requires full visibility of each stage of the mining process to ensure that it's efficient and running to schedule. You can't fix what you can't see, and we do aim to give mine sites full visibility to which for an OPEX model collects, digests and delivers accurate data and insights. So our system has a number of stakeholders or applications, but for the purpose of this presentation, we'll focus on surveying and mapping. Putting it simply, we create 3D models and 2D maps. We have a number of sensors on our system, and this includes our mapping payload, which is your typical Sony a6000 camera for photogrammetry, a number of 30x optical zoom video sensors, which also have thermal infrared cameras, and our LiDAR. LiDAR is our preferred sensor with about 80% of our flights undertaken using LiDAR. And we find LiDAR to have the best properties in terms of accuracy, repeatability, and resolution and turnaround time, and also the ability to map day and night with minimal overlap requirements. So what you can see here is what a typical day of LiDAR mapping looks like on our sites, and we call this the octopus. We're not concerned with mapping the entire mine site, only focusing on areas of change. Our air base will be located somewhere around here, and the mission planning and prioritisation is again one of the roles where we look to integrate with survey and planning and understand these areas of change so that we aren't picking up, like, maximising our flight time. And our mission planning is critical to our success. So often if we were, say, picking up a stockpile or a dig face, we would travel down a haul road, pick up the data, then travel back via another haul road so that further analytics can be performed. However, the value of an automated system is in the frequency. This daily data delivers unique insights which has not been possible. We can accurately quantify material movement, stockpiles, dig faces, and scraper and dozer activity, and give objective data on haul road construction. Sorry, that's not actually playing at the moment. Ensuring daily compliance to schedule and design. We are looking to change the model from the need to having to request data to that data always being available and up to date for various stakeholders to use as required. And so here you can see basically the daily construction of haul roads, stockpiles changing and the likes. So dozer movement, this is one which typically hasn't been quantified in the past. A good day or a bad day was typically just the subjective opinion of a supervisor or an operator. And by capturing the daily data and doing surface-to-surface heat maps, we're able to measure the amount of volume moved and gather insights into operators' performance along with those in movements and operation. So using these daily heat maps, you can actually understand each shift's performance and understand, like where the blade has been too deep and the push hasn't achieved the required distance, or where the push hasn't been done in the most efficient manner. After quantifying what is a good day or a bad day, we can then do some investigation on these good days and bad days and understand why they were a good day. This can then be used as a training tool to try and get consistency between operators, which again allows for more optimised planning where you can actually get a better understanding of how much each person can do per day. So how has this affected the bottom line? Well, what we have witnessed through mine sites that by increasing the frequency of those at as-builts, we are identifying and rectifying material movement which hasn't been done to plan. By increasing reconciliation surveys from once a month to once a week and then once every 3 days, we are able to get a very simple way to cut down on rework. And in some cases, we're actually able to double the equipment and efficiency in terms of a completed profile. So moving on to stockpile surveys. Now, this is the drone industry's bread and butter, and it's pretty common practice now that most sites are using drones to undertake their end-of-month surveys. But what you can see here is 10 days worth of 3D mapping delivered as a 3D surface model. We generate reports like this one each day, and compliance to schedule and measure and blend management can be done on a daily basis accurately in the office. The ability to have a live inventory of your ROM will greatly assist in meeting the plan, and there's no nasty surprises at the end of the month as reconciliation is done each day. But this is what's very exciting, and it's a typical trend that we're often observing, is that there's unique insights sitting under our noses. Again, in this situation, we were tasked in tracking daily stockpile movement, but what we noticed on the corner up there was very interesting, and it opened the door to new products and insights that we deliver. So let's focus on this corner and the apparent deformations. The conditions of these roads, it's got a direct correlation with productivity through speed around the corner and safety and wear on the equipment. Over the next 2 days that were mapped, it was clear that the damaged road had been repaired. Over time, the super elevation had faded from this turn and the wheels of the CAT 785 truck had dug into the earth, causing wheel ruts and slowing down for the turn and higher wear and tear on the truck and wheels. So what we can see here is the roadworks have successfully been completed, and we now have an auditable record of road maintenance. So looking at the cross-section of the inner turn, we can see that the maintenance of the turn has provided the correct super elevation, and you can see prior, those were the 2 rut marks caused by the truck prior to the roadworks being done. So From this, we started digging deeper into haul road maintenance, and we uncovered a problem, as typically maintenance was done by section, and reporting of defects or non-compliance was typically done using subjective visual inspections. So this was a very convoluted process, as you're relying on an operator to report a defect or a bund not compliance or something like that, and then that information was then passed on to a supervisor, who then may pass it on to an engineer. Engineer may then pass it on to survey to request to pick up that area to confirm that the problem exists. So we're looking to change this model to more of a need-based model, where areas of the most need are focused on. And so we've started generating reports like this one for haul road width, which ensures compliance through turns, straightaways and intersections, or road camber through the corners, bends and the likes. And bunding heights. We're very aware that like a DTM or a surface is no good for a supervisor or operator, so we generate these easy to understand plans so that they can use to quickly fix non-conformance. But the frequency of this data, it allows us to obtain a greater understanding about what is affecting haul road deterioration. If we combine this data, and again, this is another role where I see survey taking over, and we can tell you what's happening, but we don't know why it's happening. We're not on site. We don't know why is causing this. So by combining this data with information such as weather, road composition and usage, the frequency of maintenance throughout different seasons can be predicted, and then you can stand down equipment for other seasons if it's not required. But it didn't stop there. So after further discussions with schedulers, we were informed that haul roads had been identified as the single largest cause on this specific site of setbacks in the mine plan. The schedulers had very little visibility of the completion of haul roads and aligning resources on time, which can the performance and can vary with the contractor and other considerations. So we started using our daily data and created heat maps which show the design of the road versus a LiDAR scan of the area. Colours indicate where it's been built to design, and it also provides the scheduler with an objective indication to the completion of the road. This simple PDF delivered twice a week was the first time that the schedulers had true visibility of the progress, having previously relied on radio communication. And so what this means, often these haul roads that were getting constructed, this was the critical path to access a new area of the mine site. And what was happening is that they were asking the shift boss, "Oh yeah mate, how's that haul road going along?" "Yep, all good, be done by Friday." Friday comes along, no, it's actually not done till next week. And if that's the critical path of accessing that new area, everything's then held back. By having this objective data, you can actually have the up-to-date progress, so you know that it's 60% complete. It's not going to get complete by Friday, so we can redirect more resources to this area so that it will be completed in time and things won't get held up further down the track. Now, this is key. This is sort of my true takeaway message from this presentation. Across this whole week, as we do every year, we see a new world of insights from the latest technology. In this case, we have truly only just scratched the surface. There's also many applications in tailings dam maintenance, maximising the capacity of your tailings dam, drill and blast, automated pre and post blast scans so you can investigate swell, heave, blast fragment analysis and the likes. And technology is rapidly evolving, and I invite you all to be leaders in driving this at your operation. Champion this new technology and own it. As I've just described, it has the potential to open up careers into analytics and innovation evaluation. By championing new technology and taking proactive leadership, you are the ones who are disrupting other departments and the status quo, and transforming the status quo in other departments. Technology shouldn't be feared, it must be embraced. And those who are leaders in innovation will be the ones driving transformation within organisations. Our early adopters within Tier 1 organisations, they have proven value, and we're entering a very exciting phase where we're now delivering multiple units on sites across Australia and the world. We're not, like, our value proposition, there's nothing in our value proposition about removing jobs. We provide more data and analytics. which someone has to manage and investigate. And as custodians of spatial data, I invite you all to take this opportunity to become leaders in change. Automated aerial data supports digitalisation, but not at the expense of human personnel. In this room, we have hundreds of years of experience. And that's not any cop-out to the average age in this room, but I would love to hear your thoughts and opinions, and if anyone's got any questions, feel free to reach out now or get in touch, and thanks very much.